Okay, so let's start. Okay, differentiate each of the following. So we're going to talk about rule 1 and rule 2. Okay, so actually what rule 1 means is, like for example this. Okay, first let me explain a bit about how are you going to write in terms of the presentation. So you see this is x cubed, so it's just an expression with no name. Okay, with no name. So you have two ways. You either say let y equals to x cubed, then after that you will say I'm going to differentiate the y with respect to x. Okay, so the rule 1 is the power bring down, the 3 will bring down, the x will copy down, the power here you will minus 1. So it becomes 3 minus 1, so it's 2. So basically this is rule 1. Okay, this is rule 1. So at the start here, I will just state that rule 1 is something like, if I want to differentiate, let's say AXN. So it becomes power bring down, so it's A times N, and XN minus 1. So basically this is rule number 1. Okay, so just now I mentioned this expression has no name. So you either say let y equals to x cubed, dy dx is equals to 3x squared, or you can say differentiate with respect to x, whatever is inside this bracket. So I put the x cubed inside, so it is 3x squared. So when you put the equal, after the equal, when you don't have the d dx already, it means that this is after differentiation. Okay, so this is the presentation. This is how you present. Okay. So this is rule 1. Okay, of course the dy dx, let's say for example, even if let's say some students say, can I don't let y? Okay, it can, doesn't matter. Let's say you want to say let g equals to x cubed. So you will say, okay, I'm going to dg dx. Okay, and that will means that it will be 3x squared. So this is just the rule of the presentation. Okay. Okay, let's focus and learning math here. So no grumbling or your whatever here. Thank you very much. Okay, so come, let's talk about question 1b. So this is basically rule 1. So actually basically what is rule 2? It's a bit lame. That's why I put rule 1 and rule 2 together. So over here, so I'm going to state that I'm going to differentiate with respect to x, 10x5 minus 4x cubed plus 7x. So in order to differentiate this, I actually just apply rule 1 to all the 3 terms. Okay, so the 5 I will bring down, so 5 times 10 will give me 50, x power minus 1, so 5 minus 1, so it's 4. Okay, and then after that 3 bring down, minus 4 times 3 is minus 12, x power minus 1, so it's 3 minus 1, so it's 2, and then after that plus 7. Okay, when you differentiate 7x is just 7. So let me just explain why. So we know that 7x, x is to power 1. So at the side here, you see, I'm going to bring down the 1. So 1 times 7 is 7. 1 minus 1 is 0. And we know that x to the power 0 gives you 1. And that's why it's just 7 times 1, which is 7. So the shortcut is, if you differentiate 7x, it's just 7. If you differentiate, let's say, minus 10x, of course, it's just minus 10. The logic is behind here, but you don't have to show this working. You don't have to show this working. I'm just trying to explain the logic behind why is it that differentiate 7x is just 7. Okay, so rule 2 means that when you have many terms, you just differentiate them as per like rule 1. Okay, so basically rule 2 means you differentiate the separate terms. The separate is A or E? A, right? Yeah. Differentiate the separate terms as per rule 1. Okay? So rule 1, rule 2 is just like that. Okay, let me continue. Okay, so now next one is, yes, we know that it's still rule 1 and rule 2. But you will have to be using a lot of the, what I call the Indices Law lah. Okay, so over here, so you see, I'm going to change this to a different expression first. Sorry, I think I should copy the question first. So let's write 5x4 plus 1 over x minus 1 over x squared. So what I need to do is change it to index form. So 5x4 remain the same. This x I'm going to bring it up, so it becomes plus x to the power of negative 1. So minus x to the power of negative 2. So you need to change it to this index form for easier differentiation. Okay, so let's proceed to differentiate. So I'm going to say I'm going to differentiate 5x4 plus x minus 1 minus x minus 2. So now we are ready to differentiate. So use your rule 1 to differentiate. Power bring down. So 4 times 5 will give me 20. So it's 20. 4 minus 1 is 3. So it's x to the power of 3. Power bring down. So it will become negative 1. Of course, I don't have to write the 1. So x. Minus 1, so it's minus 2. Okay. Now this one. Minus 2 bring down. Negative 1 times negative 2. So we know it's plus 2. X. Minus 2 minus 1, so it's minus 3. So then after that, you cannot leave your answer in negative index. You keep it in positive index. So you will have 20x cubed minus 1 over x squared plus 2 over x cubed. And we are done. Okay, so very important is you need to change them to the index notation. Okay, before you differentiate. It's easier to see. All good. Okay, so for the part D, it's also quite similar. The one who said hard sia, are you learning properly, as in like, are you doing AMath Sec 4? Or are you just commenting that it's hard sia? Okay, because I only want to respond to those who are actually really asking me genuine questions. Like if you really don't understand and you want to learn this topic, then you tell me to explain the question again. I am happy to do so. Okay, but your hard sia, I don't know whether I should explain or not. So those who are listening, can I proceed to part D? Nobody learning here. Wow. Anyone listening to what I'm teaching for the 5 rules differentiation? No one in class today? Can I continue? Okay, I know you are listening, but take note that I don't like to see capital letter inside my chat. And my moderator are very sensitive. Seeing capital letter means is equals to root. Okay? Explain the negative convert. Okay, can. So it's actually indices rule. So let's take a look over here. I put red color. So actually it's indices. Indices is learned in Sec 3E Math. Okay, learn in Sec 3E Math. So let's say for example, when we have the rule is, let's say how am I going to explain? Okay, let's say I have x m. Should put number. So let's say I have x 4, x minus 4, x minus 3, let's say y 5, and y minus 4. This is minus 4. Okay, so indices law tells us that when it is negative power at, let's say, the numerator, you just need to bring it to the bottom. Okay, if it's negative at the bottom, we just need to bring it up, then it becomes positive. So in this question over here, this x minus 4 is negative at the top, right? So you bring it down. This x minus 3 is negative at the bottom, right? So you bring it up. So of course, when you switch numerator to denominator and denominator to numerator, the power becomes opposite sign. So the y5 is already positive at the numerator, so we just leave it as y5 as the numerator. Then the y minus 4 is negative at the denominator, right? So I'm going to bring it up. So the y4 goes up. So to simplify it, in the end, you can see that x cubed and x4, the x cubed cancel, right? So you're left with a x4 minus 3, so you're left with a 1. So this y is multiplied, so you add the power. So it becomes y9 over x. So this is how you deal with negative index. So in this question, just now over here, this one, okay, the 1 over x, okay, so it is like in this form, it is positive at the denominator, so we bring it up, so it becomes x to the power of negative 1 at the top. Agree? But of course I don't need to put the over 1, so it's just right as x to the power of negative 1. Same likewise for this 1 over x squared. So I want to make it index form, so I bring it up, so it becomes x to the power of negative 2. All good? Understand how the index, the negative index work? Just box it up. If not, it looks so untidy. All good? Can, okay. So let's continue. So over here, same thing. I need to change this to the negative index as well. So, no problem. So see here, just now was easy. Why? Because just now was 1 over and 1 over. So now you see that we have fractions. So now let me just copy the question first. So it's 7 over 2x4 plus 5 over 3 x4 plus x. So let's change it to the negative index or the index notation accordingly. So this x4 is already in the index notation, so we don't have to touch it. So 7 over 2x4 remains as it is. This one, do you see that the x to the power of 4 is at the denominator? So we have to bring it up. So it will be plus 5 over 3x to the power of negative 4. Okay, this plus x has no change, so it's just keep it as plus x. Can? So now we are ready to differentiate. Okay? Very important. So just at the side, although those who learn A math, this should be easy for you, but you see, you must understand, you must know that, let's say my x4, for example, if the x4 is at the numerator, okay, you can write it, of course, as 7 over 2x to the power of 4. When it's at the numerator, it can be in the middle. Okay? But if, let's say, I have 7 over 2x4, this x4 is at the denominator, you cannot just pluck out and become this. So I will just say this is not correct. So just need to take note how you're going to manipulate the algebraic. Okay? CQ Cheng, thank you. Okay? So now I'm ready to differentiate this. Okay? So I will say, okay, I'm going to differentiate 7 over 2x4 plus 5 over 3x minus 4 plus x. So equal. So now I'm ready to differentiate after. So same thing, apply our rule 1. Okay? Power bring down. So it's 4 times 7 over 2. So of course, no need to stress yourself. Press calculator. Okay? So it will be 4 times 7 over 2, right? So 4 times 7 over 2. 14. So that means this is 14x power minus 1. So 4 minus 1, so I get 3. Now minus 4 bring down, so it's 5 third. My other multiply. So 5 third, 5 over 3, multiply by negative 4. So I get minus 20 over 3. So I know this is minus 20 over 3 x power minus 1. So minus 4 minus 1, so I get minus 5. So remember just now when we differentiate plus 7x, it's just a plus 7. Thanks for the nasi lemak. So differentiate plus x, actually there's an invisible 1 there, so that should become plus 1. Okay, but don't leave your answer that because answer we don't like to have negative index. For us to change to a negative index here in the beginning is for easier differentiation. So a lot of students always tell me, you're so troublesome. Can one, I can visualize one, you know. Yeah, of course you can, but if you don't practice your basic and foundation, okay, later part when the question gets tougher, trust me, it will get tougher. These skills that you now practice and understand, okay, is important for the behind kind of a question. So trust teacher Kangie to follow the steps that I do. You will thank me and pray that teacher Kangie is a savior that she teach in this manner. Understand? What's that one? Burger, cannot see. Oh, roti. Thanks for the food. Luckily teacher Kangie eat dinner already, so not so distracted by the food today. Okay, so after that we need to change this to positive. So the 14x cubed remain minus 20 over 3. This x minus 5, I'm going to bring it down, so it's x to the power of 5, then plus 1, and we are done. All good. So let me see. Yes. So this is part D. Anyone need me to further explain part D? If not, I will move on. Okay, I always want students to really master the 5 rules. Very important. Okay, thanks for the follow. So those who haven't followed me but are listening and enjoying, please follow. If not, later when I do TikTok live, you might not get reminder. When I do TikTok video, you also never receive notification. Correct? Okay. And also help me to like and share to your classmates, those who actually always sucks at math. Let them, or they always do TikTok, watch TikTok, never really learn their math properly. Send it to them, share it to them and make them learn the math from me. How do you study for your math exam last time? Math is really, hi Minecraft, math is really about learning the concept and not memorizing. Okay, you have to understand the concept and then practice. Okay, you have to always practice. Path. Yeah, some students, some of my adult friends also say that they follow me because they enjoy listen to me teach maths. Reminds me of my Form 4 and Form 5 A maths and maths. It was so fun. Actually, math is actually very fun. Of course, students who cannot do the question, then they will find it not fun. But once they understand the concept and know how to solve it, it's actually very satisfying. Okay, now look at this. Okay, common mistake that students, after they learn all the 5 rules, they will ask. They will see, something times something. Then they will say, okay, I'm going to apply product rule. Okay, product rule I haven't teach you. Okay, product rule I haven't teach you. Okay, but for this case, I will not apply product rule. Why? Because you must always remember that rule 1, rule 2 is the easiest. So when we can actually look at expression and see whether we can simplify to just a single expression, if we can, then we can just apply rule 1, rule 2. And no need to apply 3, 4, 5. Okay, should I stop NITEC and take private O level? If you are doing fine in NITEC, why do you want to stop and take private O level? So it depends on your path lah. So of course NITEC can also get to the higher NITEC, is it? And then after that also can go to poly. So it depends on what your path lah. If you want to take private O level, you must know private means what? You are all by yourself. You have all the freedom, and it means that no discipline. You have to discipline yourself to really study, okay, and really find the help that you need to for the study. So just sharing that I recently got a new student from TikTok. She's 28 years old, taking private O level AMath. Yes. So want to encourage her that at least she knows that she wants to do it. Okay, so she signed up with me and she's very hardworking. So I wish her definitely all the best, and we will work hard together. Okay, let's see. Are we supposed to expand this? Yes, Mock Jack, you are right. Okay. Yes, expand as it will be easier than product rule. Correct. So every time before you apply rule 3, rule 4, or rule 5, always ask yourself whether you can change them to single expression. So this one by rainbow, I can change it to a single expression. So I write down the question first. X cubed plus 2 and x squared minus 1. So do the rainbow. This one times this one will be x to the power of 5. This one times this one will be minus x cubed. This one times this one is plus 2x squared. This one times this one is minus 2. Hey, cannot simplify it. No like terms. So this is the expanded form, which is the single expression. So now I'm ready to differentiate. So let's differentiate this x5 minus x cubed plus 2x squared minus 2. Yes, this one is AMath Sec 4. Differentiation. I don't think normal tech got AMath. Okay? Not I know of. I don't think there is. Okay? So let's differentiate using our rule 1. So power bring down, so it's 5x, power minus 1, so it's 4. 3, so it's minus 3x squared. 2, so plus 4x. When you differentiate a constant, it is 0. Okay? Again, although it's a shortcut, but the theory behind is just here. For those who are you know, the very curious one, why is it that it is 0? So when let's say you want to differentiate a constant 2, okay, let's say minus 2 doesn't matter. So actually, do you agree that actually I'm differentiating minus 2x to the power of 0? Because x to the power of 0 is 1, agree? So if I differentiate, power bring down is 0 times negative 2, right? 0 times negative 2 is 0. Okay, of course this one doesn't make sense because 0 minus 1, we don't get x minus 1. Okay, then after that, if 0 multiplied by, be it even it is. So even if let's say it's like that, because it's the whole thing is become 0 already. Okay, so that's why it's 0. So when you differentiate a constant, it's just 0. Understand? So this is the final answer. Okay, so now let's move on. Okay, so let's see. This one, same thing. Okay, when students see this to the power of 2, they say, okay, I'm going to apply my rule 3, which is the chain rule. But teacher Kangie say that again, always see whether you can make them into a single expression to apply rule 1, rule 2. This one is just square. I can just rainbow and make it into a single expression and apply rule 1, rule 2, correct? So I will just write out the question first. So x squared plus 2 over x squared, I will rainbow this. So either you use the a squared plus 2ab plus b squared, or you just put the a plus b and do the normal rainbow, up to you. So let's say I'm going to apply the a squared plus 2ab plus b squared. So a squared will be x to the power of 4. Okay, plus 2ab. So let's say I will write it out 2ab, and then after that plus b squared. Okay, so let's simplify this. Okay, so this is x4, of course. Look at this. So 2 times 2, so we know it's 4. This x squared times 1 over x is just x, because I cancel the x, this one is x, so it becomes 4x. So the middle becomes 4x. And this one is 2, so it's 4. X squared, so it's x squared. Okay, but we are not done yet. Again, because I have an x at the denominator, so let's change this to index notation. So x to the power of 4 plus 4x plus 4x minus 2. So now I'm ready to differentiate. So let's differentiate. So I'm going to differentiate this x4 plus 4x plus 4x minus 2. So power bring down, apply rule 1. 4 bring down, so it's 4x. Power minus 1, so it's 3. Then differentiate 4x. Remember the shortcut is just a 4. This one power bring down. Minus 2 times 8. Minus 2 times 4 is minus 8. So it's minus 8x. Power minus 1, so it's minus 3. So leave your answer in positive index. So it will be 4x cubed plus 4 minus 8 over x cubed. Okay, so the answer is just that they rearrange this one, but it doesn't matter. Okay, so this is the answer for part F. Okay, all good. Okay, so I think the tough part over here is about the rainbow because the terms is not so straightforward, right? So just analyze it this way a squared plus 2ab plus b squared. So you can see, so it's easier for you to see. 2 times 2, so it's 4. X squared divided by x, so it's x. Okay. Thanks, cheerful. Okay, so let's move on. Okay, I have one more question for rule 1 and rule 2. This is also another common question. As in like, okay, students see this question, what will they say? Oh, I'm going to use the quotient rule, right? Because they see, oh, numerator got x, denominator also got x. Then I'm going to use the quotient rule, but wrong. Again, you need to analyze and see whether this one can it become a normal expression. So whenever you have a fraction, if your denominator is only one term, please split it. So now I'm going to write the question. So 3x squared plus x. Sweetheart. Yes. Okay. Divided by square root x. So I'm going to differentiate. Oh no, sorry. I'm not going to differentiate. I'm going to split this because my denominator is one term. So it is actually 3x squared over square root x plus x over square root x. Agree? So you can think this way. If let's say I have this. Because I have the same denominator, if I combine it, it becomes 3x squared plus x over square root x, correct? So it's the same thing. It's like doing backwards. I'm splitting it into the two with the same denominator because the middle is a plus. Okay, so by doing this, still not ready for differentiation. I need to simplify. So square root x is x to the power of half. So this means is I'm going to write 3x squared because this is half, right? So it's minus half plus x. This is 1. So 1 minus half. Okay, this is a bit more about using the rules of indices. So let's simplify. So 3. So 2 minus half is 1.5. So I always write in improper fraction. So it's 3 over 2. This will be half. So you see, I didn't use quotient rule, okay? I split because my denominator is one term. Split into 2, simplify it, so it's still in the index notation. Now we are ready to differentiate. So I'm going to differentiate 3x 3 over 2 plus x to the power of half. Okay, for students wondering how did I do this step to this step, it's I'm going to do this 3x squared over square root x at the side. So I'm going to change square root to become the power. So it's 3x squared over x to the power of half. Okay, and because it's divide, if I write it as 3x squared divided by x half, we know that when we divide with the same base, you minus the power. So it's actually 3x2 minus half. And that's why I get 3x 3 over 2. Okay, so this is the so-called magnified steps for those who are wondering how do I get from here to here. But it is actually because of this indices rule. Okay. So now let's ready to differentiate. So differentiate based on rule 1, power bring down 3 over 2 times 3. So you know that, although this one obvious is 9 over 2, but to play safe, okay, we put 3 over 2, and then after that times 3, 9 over 2. Then after that, we know this is 9 over 2x, power minus 1. So 3 over 2 minus 1. Those who are not confident in fraction, just press calculator. 3 over 2 minus 1. Okay, so over here, put half. So 3 over 2 minus 1 is just half, plus power bring down, so it's half x, half minus 1. So half minus 1 is negative half. Okay, so half minus 1 is negative half. So you just put minus half here. So again, you don't leave, okay, for square root, for half, you don't leave your answer in half. You put it back to the square root thing. So after that, no, quotient rule is the most toughest among all the 5 rules, okay? So usually we don't use the quotient rule unless it's necessary. Okay? So now this one, I will change it to 9 over 2 square root x plus 1 over 2 square root x. So you can see that because it's minus half, so I bring it down to the denominator to be square root x. Okay, sorry, so my moderator has, you are not rude, but the thing is because we are talking about irrelevant stuff, because we are learning AMath here, the students want to ask questions, I might miss out their questions. So my moderator muted you. Okay. So over here, so all students understand? So before I go to rule 3, let me recap a bit. So basically rule 1 is just power bring down. Okay, power bring down and then power minus 1. Right? And then rule 2 simply means that many terms just apply rule 1 for each of the terms. And over here, I've done that when you see fraction, what you need to do is just change them to the index form before you differentiate. And then you just apply rule 1 and rule 2. Okay, so this is also the same. It's just that here deal with some fractions. Okay, then after that, I also went through some questions. Okay, I'm also going through some questions whereby this type, whereby a lot of students see they will apply product rule. But like I mentioned, this can rainbow to become a single expression. You can just apply rule 1, rule 2, simple. And then this one also the same thing. Students see this kind of question, they apply the chain rule. But actually no need to apply chain rule. You can just rainbow, become a single expression, and then just differentiate applying rule 1 and rule 2. And the last one, which is this one, a lot of students will use quotient rule, but again, you don't have to. You can just change this, and it become a normal single expression, and then just differentiate as per rule 1 and rule 2. I did binomial questions before in my YouTube channel, or in my previous TikTok live. You can always take a look. Okay, so before I continue, maybe you can just talk a bit about my Telegram channel as well as my YouTube. So you can go to my TikTok bio. Click on the, there's a few buttons, right? So the bottom 2 buttons, one is go to my YouTube channel, whereby you can see some free e-math lesson and some AMath lesson. And all my past TikTok math live are posted on my YouTube channel. So please go and subscribe so that you can actually, if you want, you can go and scroll and find whatever topics you want. Then as for my Telegram channel, which is the last button on my bio, click on that and join my Telegram channel. So Telegram channel, every Monday I will post some random thoughts. It can be inspirational or some emotional stuff. Of course, not crying stuff. It's just, yeah, every Monday. And then we will post the worksheet like the one that you see here. Of course, you will see one which is the empty one without my working, and then behind it you will see my solution. So whatever you see me do today, it will be attached to that PDF, and then it will be uploaded on the Telegram channel. So from the Telegram channel, you can download that worksheet to do, and you can scroll a bit and scroll here and scroll there. You can see that I also previously got upload some past school exam paper for your practice. So you can download from the Telegram channel. Okay? Yep. And of course, don't forget to like and share. Okay, and follow me. Okay, let's continue to rule number 3, chain rule. Sec 1 AMath simultaneous is not say one of the easiest questions to score. Actually, basically the AMath, to be honest, they seldom really come up with one questions and tell you to solve simultaneous AMath. But for those who are already learning Sec 4A Math, you know that actually practically almost all questions you need to form two equations and solve simultaneous. So in other words, your your simultaneous equation skills must be very strong because it applies to all questions, almost all questions. Okay? Okay, so now let's take a look. So chain rule. Chain rule. So over here, you look at this question. 3 minus 4x to the power of 8. Okay? So remember just now I have to the power of 2. So I can rainbow and just apply root 1, root 2. So to the power of 8, of course, technically speaking, you can use your binomial to expand and then do your root 1, root 2. Okay? But that's a bit tedious lah. So when you have, usually when you have power 3 and above, okay, I will not go and rainbow lah. 3 still can rainbow, but it's too time consuming. So we apply our chain rule. So the way I do my chain rule is not the same as school lah. So usually school like to say let u equals to 3 minus 4x, then do your du dx, then after that dy du equals to du that. But I don't like to use that one, too long-winded. So what I do is, so first, because this one no name, right? So maybe let's say this time round I'm going to say let y equals to 3 minus 4x to the power of 8. So my dy dx, so actually this is quite similar to if I say it is x to the power of 8. When we want to differentiate x to the power of 8, we know we bring down, it becomes 8x to the power of 7. So actually it's quite similar. It's just that this bracket is not x. So you just power bring down, so it's 8. Just copy this bracket, power minus 1, so it's 7. Correct? Then do one more additional step, which is multiply by differentiate the inside, which is inside the bracket. So differentiate the inside the bracket as per whatever rules that you have lah, which is root 1, root 2. So this one is just negative 4. So it will be minus 4. So then of course you need to simplify. So 8 times negative 4 is minus 32. So it's just minus 32, 3 minus 4x to the power of 7. Very straightforward. Okay. So for me is I don't use the u lah. I will just say, okay, power bring down, copy, power minus 1, multiply by differentiate inside. And then just simplify it. Okay, so next. So now we are at rule 3, which is the chain rule. Checking the time, okay, 9 o'clock. So let's see whether we can finish 5 rules today. If cannot, I will just continue on Sunday. Okay, Sunday there's another live which is 5 to 6:30. Okay, this one. So for this, actually we can apply chain rule. It's just that you need to change a bit of the presentation. So I'm going to differentiate this 5x minus 3 to the power of 6 to the power of 8. I'm actually just writing the question out. Not ready to differentiate yet because this doesn't look so simple to differentiate. So, but if I'm going to change this presentation to look like that, 1 over 8, 5x minus 3 to the power of 6. All agree? At least I learned 10% today. At least I know some new things I don't ask because it's for Sec 4. Yeah, okay? So what I did is I just changed the presentation. So I write it as 1 over 8, 5x minus 3 to the power of 6. So now I'm ready to differentiate. Now it's easier to differentiate. So power bring down, so it's 6 times 1 over 8. So what you need to do is just 6 times 1 over 8. You will get 3/4. So you will write it as 3/4. Copy the bracket, power minus 1. Right? Multiply by differentiate inside, which is 5. Okay? So then after that, you have to simplify. So 3/4 times 5 will give me 15 over 4. So you will write it as 15 over 4, 5x minus 3 to the power of 5. Done. Okay, so I repeat, I just change the presentation. So I just write 1 over 8, then after that this way. And then after that, power bring down, 6 times 1 over 8, I get 3/4. Copy the bracket, and then after that, power minus 1. Multiply by differentiate the inside, which is 5. Then just simplify. So basically that is chain rule. so let's move on. Okay, so this question over here. Okay, Yong, 加油. Master the simultaneous, very important. Okay, so again, this one, I'm going to apply the chain rule as well. But again, it's not ready yet. So you need to change the presentation. So I want to differentiate this. So 1 over x squared plus 2 cubed. You can see that I always have the habit to write the original question first. Then I need to change this up. Remember just now our rule 1, rule 2, I teach you all to change this something like 1 over x cubed. You become x to the power of minus 3. Remember? Yes, that's where. Wow, that's a good thing to know. Is it easy to score A1 for AMath in Sec 5? Nothing is easy if you don't put effort. Yes, Yong, I will strive for A1 and avoid careless mistake. Okay, Yong, maybe now you change the statement. You will tell yourself, yes, teacher Kangie, I will strive for A1 and I will be more careful. Use positive word, be careful, rather than always listening or seeing the word careless. Okay? Okay, so now, see, remember just now I teach you this one, right? So now, you are going to apply that. So I'm going to change this to the presentation. It becomes x squared plus 2 to the power of minus 3. So that's where it has your, just now what we have learned, the foundation is important here. So now power bring down, so it becomes minus 3. Copy. Power minus 1, so it's minus 4. Multiply by differentiate inside, which is 2x. So let's simplify this. So minus 3 times 2x is minus 6x. And since because this one is minus 4, so later I'm going to bring it to the denominator, right? So this is become minus 6x over x squared plus 2 to the power of 4. And we are done. Okay, so I repeat, what I did was, I make use of the skill that we learned in the rule 1, rule 2, bring it to the, change the index form, and then after that, apply rule 1 actually. So minus 3 bring down, power bring down, copy power minus 1, multiply by differentiate inside, which is 2x. And then just simplify. Minus 3 times 2x is minus 6x, so the minus I put it in the middle. And then this one, because it's negative 4, so positive index means I bring it back to the denominator. That's all. Please do possibility. Sam, can you help me to take note, like some of the topics that students sometimes request, then maybe you can highlight to me. So sometimes I need to headache what I need to do for the next live. Like this student request for 3 diagrams. So maybe next one of the live lesson I can actually do that. Okay, so now let's move on. Okay, so let's take a look at this one. So this one, some students will struggle. So actually this one is not as complex as you think. So let me just write out the question first. So it's 12 over 2 plus 3x squared. Okay, so some students will be stuck at like plus then what do I do? Actually this one is, I just need to change it to index notation. So d dx, it will be 12. Okay, I can use square bracket with you. Then after that 2 plus 3x squared to the power of negative 1. Do you see that? Okay, the 12 is just at the side, then I bring the denominator, the whole thing bracket to the power of negative 1. This is just what I did. Okay, so it's just changing to index notation. So now we are ready to differentiate. So power bring down, minus 1 times 12 is just minus 12. And then after that 2 plus 3x squared. Power minus 1 means minus 2. Multiply by differentiate the inside, which will be 6x. So I just put it here. So we know that this one will be minus 72x over 2 plus 3x squared to the power of 2. And we are done. Alright. Okay. So, anyone else need me to further explain this question before I move on? All good? Wow, I got football. Thank you. Okay. All good. Can I proceed? Can I proceed? Anyone need me to explain this question again? If not, also give me the cue that I can proceed. Oh, nobody listening in class. Oh no! I'm going to cry already. AMath trigo is a very big topic. So yes, in fact, you already have to relearn the AMath trigo. I have some AMath trigo videos in my YouTube channel. You can go and search lah. So I'm going to explain this question again. So over here is basically, maybe this one I put square bracket. So actually, I'm just changing it to the index notation. Example, if today I have 12 over x, if I want to change this to index notation, do you agree that it's just 12 x to the power of minus 1? Agree? So it's the same likewise for here. So this whole bracket is just like the x here. I'm just bring it up, so it becomes to the power of negative 1. And then after that, I just can differentiate as per rule 1. So power bring down, negative 1 times 12 give me negative 12. This one just copy, power minus 1. So minus 1 is minus 2. Multiply by differentiate inside. This is chain rule. So multiply by differentiate inside. And inside, over here, differentiate 2 is just nothing. Differentiate positive 3x squared is just 2 bring down, 2 times 3x power minus 1. So it's 6x. So after that, what I did is minus 12 times 6x is negative 72x. So negative is here. 72x I put at the numerator. Because this one is minus 2, I know I need to bring it to the denominator as positive 2. That's all. All good. So, PJ Math. So I explain this for you. Do you understand? How? PJ Math? Can or not? Good. Okay. Okay, this is E. Okay. So over here, a bit similar. It's just like if today I have 3 over 4x. If I want to change it to index form, it will be 3/4 x to the power of negative 1, correct? So same thing, this one, so let me write out the question. So differentiate 3 over 4, 5 minus 3x squared. So I'm going to change the form first. See, when I'm changing the form, I'm not differentiating. That's why you see that my d dx is still here. So I just change it to 3/4, 5 minus 3x squared to the power of negative 1. So all I did was so-called bring the x to the top, so it becomes to the power of negative 1. So it's just that over here is a bracket. So I bring it up, so it's to the power of negative 1. So I'm ready to differentiate. So power bring down, negative 1 times 3/4 is just minus 3/4. Copy. Power minus 1 means minus 1, so it's minus 2. Multiply by differentiate inside. So when I differentiate inside, differentiate 5 disappear. Differentiate this one is 2 times negative 3, so it's minus 6. Then 2 minus 1 is 1, so it's minus 6x. So this one is minus 6x. So this is minus 3/4 times negative 6, right? So just key in negative 3/4 multiply by negative 6. So we get 9/2. So we have 9/2. Don't forget we have an x. So put x here. Yeah. Okay, by right I need to bring this down. Never mind, we will bring this down the next step. So to rewrite, it become 9x over 2, 5 minus 3x squared to the power of 2. Done. Okay, so this is a bit similar to just now that one. The only difference is it's not one whole. It's a fraction, but it is similar. Sam, this one the answer sheet should be 9x. This one. Sam. Then can acknowledge that you hear what I say. Oh, Michelle, can you take note and let Sam know? Okay, let's continue. I don't know why my moderator is not responding. It's my TikTok jam. Or my moderator all fall asleep. Hello? Okay, Michelle, thanks. Thanks for the response. Okay, so let's continue. So f, so this one is square root. So remember previously, okay, when we have square root x, we say that square root x is to the power of half. So we change it to x to the power of half, right? So same likewise for this, okay? So same likewise for this, you will say that I'm going to differentiate this square root 3x cubed minus 4. I will change this to differentiate 3x cubed minus 4 to the power of half. Okay, so now we are ready to differentiate. Okay, hello Eric. Okay, so bring down the power, so it becomes half 3x cubed minus 4. Half minus 1, so it's minus half. Multiply by differentiate the inside. So 3 times 3 is 9, so it's 9x squared. So it's 9x squared. Congrats! Congrats for getting an A1 for both E-Math and A-Math. O level today. O level results today. Okay, so then let's continue. So let's simplify. So you see, because this is minus half, so we know eventually not to, B3 for E-Math, not so bad already lah. I think, so for this case, there is bell curve, as in like students who expect to get A1, in the end they get a band down, right? So, but it's something that you cannot control. As long as you did your best, then the next step is to find out what's the next step. Be it whether are you going to retake, be it whether you are going to go and source for the course that you're going to go for the next 3 years. Okay, let's move on. So since this one is minus half, so I know I need to be a fraction, right? So let's put a fraction first. Okay, so this one will go down. It will become, okay, before I write that one, I will write the 2 first. And the 9x squared belongs to the top. So I put it here. So the 2 will be here. And then this will be square root 3x cubed minus 4. Why this one is square? Okay. So this one is cube. So Michelle, help me to take note, is 3x cubed. So we are done with this question. Okay, we still have 2 more questions for the chain rule, then we will move on. Is it? No, we have 3 more questions for chain rule before I go to the product rule. So let's move on. So let's see. So again, okay, see this. So I put at the side here. If today it is x cubed root x, we know that we change this to x to the power of 1/3. So likewise for this. So to differentiate this, we will change this to 2x squared minus 5 to the power of 1/3. Okay? So now we are ready to differentiate. So power bring down. So 1/3 bring down. So it becomes 1/3 2x squared minus 5. 1/3 minus 1. So 1/3 minus 1 is negative 2/3. Multiply by differentiate the inside. So it's 4x. So we know that this is minus. So I know I need to be a fraction. So I put a fraction. 4x will be at the numerator. This 3 will be here. So this is 2/3, right? So how am I going to write my 2/3? So I'm going to write here. If today is x to the power of 2/3, I will write it as x cubed root square. So we need to know that denominator 3 is the root, the 2 numerator is the power. Okay? So I wrote at the side here so that you can see clearer how I shift those bracket. So then over here, it means that I will write it as 2x squared minus 5 square, then with a cube root. So this one a bit tricky. Why? Because there's a small 3 here, there's a big 3 here. Correct? So if you want to look neater, you can write it as 4x and then put a 3 and then a bracket, cube root 2x squared minus 5 square. Also can. Okay, this is fine. It's just that make sure that your 3 have to write mini 3. So let's say this one is my answer. So let's see. So of course, answer over here is put 2/3, but it doesn't matter. You put as a 2/3 or you put it in this form, it's fine. I will prefer to put it in this form, because I don't like to write my power as a fraction. Okay, so let's move on to the next one. So this one is actually okay. Differentiate 2/3 2x squared minus 5. So going to change this to index notation. So it's actually 2/3 2x squared minus 5 to the power of half. Why it look like similar? No, it's not. Okay. Okay, that one is cube root. Okay. So same thing, power bring down. So you see by now, you're already like by heart already so easy. Just always power bring down, power bring down. So you just need to master changing to index notation. So half times 2/3, 2/2 already, press calculator. Half times 2/3. So it gives me 1/3. So it gives me 1/3, bracket bring down, power minus 1, half minus 1, so it's minus half, multiply by differentiate inside, which is 4x. So minus half, so I know I will be a fraction. 4x, put it at the numerator. This 3 will be at the denominator. This minus half means it's square root. So it's square root 2x squared minus 5. Done. Wow, did I write wrongly? Why is it that this one and this one is totally different? I know why already. This is supposed to be cube root. Let's see. So we will change the question a bit. So I'm going to just cancel the answer here. Okay, so this one is this answer over here. Oh, someone subscribe to my YouTube channel. So sorry, the original question is supposed to be cube root, whereby this is a small 3. Okay, but there was a typo mistake, so I thought this is a big 3. Okay, this is my mistake, and so I work it out as a big 3. Okay. Oh, I realized the mistake I did. Oh my god. Random, you're right. Okay, oh my god, should I correction tape? Wait, let me see. Okay. Rewind. So this is a mistake, correct? Okay, because this one bring up supposed to be negative half. Let's redo. My bad. Thanks for pointing out. Okay, let's redo. Alamak. Now it looks like the vegetable already. So 2/3 remains as 2/3. This one bring up should be negative half. So we should bring down the negative half. So it should be negative half. So it's minus 1/3. So this one is supposed to be minus 1/3. And then after that, this one 2x squared minus 5, power minus 1. So minus half minus 1, so it's minus 3/2. Multiply by differentiate inside, so it's 4x. Okay. So let's simplify. So we have to go to write as a fraction. So we have minus, so it will be minus 4x at the numerator. Then over here, this is 3. This one, okay, I'm going to put at the side here. So x 3/2, you will write it as square root x cubed. The 3 is here. This half, so-called the denominator 2, is this square root. Yes, this is differentiation. Okay, so we will write this as square root 2x squared minus 5/3. So now is this correct already? Yeah, correct. So this one answer is correct. Ignore. Answer is correct. Okay. Okay, so let's move on. We are done with rule 1, rule 2, and rule 3. Okay, so it's already 9:20. So I don't think I can finish rule 4 and rule 5 today. So maybe I will just start a bit on the rule 4, which is the product rule. But because product rule is actually quite a complex part whereby, yeah, I don't think I can do it within 10 minutes. Oh, I still got one more question for chain rule. Okay, let's do this chain rule first. So over here, okay, this is the tough part whereby the inside bracket, okay, so kids, if you notice, just now all the inside bracket is easy to differentiate. Okay, the inside are quite easy to differentiate. But this one, look at the inside. So inside is x plus 2 over x. So it's a bit tougher to differentiate. So it's okay. Just do step by step. So differentiate with respect to x. X plus 2 over x to the power of 1/3. So same thing, this one straight away just apply the chain rule. So power bring down. So it's 1/3 x plus 2 over x to the power of 1/3 minus 1 is minus 2/3. Multiply by differentiate inside. Okay, now the bad news is differentiate inside. This one of course is easy. Differentiate x is just 1. But the question is how you differentiate the 2 over x. So the tough one, I will write it at the side. So you can differentiate this 2x to the power of minus 1. You can do it separately. So actually, okay, so I put it over here. So differentiate this one is just power minus 1. So it's just 2 times minus 2, 2 times negative 1, so it's minus 2. X power minus 1, so it's minus 2. So this one actually rewrite as positive index 2 over x squared. Then I just need to put here, right? Multiply by differentiate inside, which is 1 minus 2 over x squared. Agree? Then after that, I just need to simplify. So let's see. So actually no need, you see the answer is just like that. Because this one, if I bring it down, is quite tedious also. Because this one, if I'm going to bring it as a denominator, then this one I say I need to change to the single fraction. So this one we can just leave it as it is lah. It's fine. Yeah, this is good enough. Anyway, the answer sheet is also like that. Ta-da! Okay. So no equal. So over here, this question is what I'm trying to state is when you want to differentiate inside, it's a bit tough for, let's say, one of the terms, you can do it separately. And then after that, just plug it back here. Okay, so we are done with the chain rule for today. So let's do a bit about the product rule, just in case, because I will only continue the product rule and chain the quotient rule this coming Sunday. So if some students maybe already start teaching product rule, and if let's say I talk a bit about product rule, then maybe it helps you a bit in school. Okay, so let's take a look at this question 3a. So this is a typical question whereby I don't need to apply product rule, right? So this one is just 2 bracket and you look at the power, both is 1. So actually all I need to do is just do my rainbow first. So I will just do rainbow for this one and not apply product rule. Although this is in the product rule. So just rainbow. This one times this one will give me 6x. This one times this one minus 3x cubed. This one times this one plus 4. This one times this one is minus 2x squared. So check whether there's any like terms. Don't have. So that means I straight away can differentiate. And then after that, 6x minus 3x cubed plus 4 minus 2x squared. Okay, so let's differentiate. So differentiate 6x is just 6. This one bring down, so it's just minus 9x squared. Differentiate 4, okay, it's just nothing. So this one bring down, so it's just minus 4x. So they just rearrange. Okay, actually it's the same. They just put it as 6 minus 4x minus 9x squared. So student may ask, I thought you usually put the x squared at the front. Okay, but because it's minus 9, so usually they don't like to put negative in front. But it doesn't matter. Okay, of course, unless the question say put in ascending power of x or descending power of x, then it matters. But if it never say, then it doesn't really matter. Well, Joseph, thanks for sharing. Okay, so let's continue this part. So this one. Okay, so the question is, am I able to rainbow this one? This one is square root x plus 4. So, but before I so-called analyze it, let's see. So this one is x minus 3 bracket x plus 4 to the power of half. So if you look at this one, am I able to rainbow this? To the power of half, there's no way I can rainbow. So because I cannot rainbow, I cannot change it to a single expression, so I have to apply product rule. So this is how I do my product rule. So of course in school, teacher will use the U and then got the V. Okay, but I never use the U and V. Teacher Kangie a bit lazy. I just so-called memorize the method to differentiate. So this one, because I want to use product rule, so let's start. I'm going to keep left, and right here, keep left, okay, differentiate right, plus keep right, differentiate left. Okay, so keep left, differentiate right will be bring down the half, because I apply chain rule. Bring down the half, so x plus 4, half minus 1, so it's negative half, multiply by differentiate inside. Although differentiate inside is just 1, but please make it a habit. So you always remember that chain rule need to differentiate the inside. And then because I got no space here, I just write it here. So plus, now I'm going to keep right, so it will be this one. It will be x plus 4 to the power of half, differentiate left, which is 1. So let me just write it slightly nicer. So it looks like half x minus 3, x plus 4 to the power of minus half, plus x plus 4 to the power of half. This is a tough part. So how am I going to simplify this? Okay, a lot of students don't understand how to simplify this. So maybe let me see. Okay, so if I'm going to write it as at the side here, half y x minus half plus x half. Okay, imagine if it's like that. Okay, I want to take out the common factor. So common factor, we always take the smaller one. So I'm going to take out x to the power of negative half, because negative half is smaller than half, correct? So I'm going to take out x to the power of negative half. So all you need to do is, I'm going to take out x to the power of negative half, open bracket. So this one is just half y. And this one, half, when I take out minus half, is half minus minus half. Half minus minus half, end up half plus half, which is 1. And that's why this one becomes plus x. Okay? This x to the power of half, I'm going to take out x to the power of negative half. So it's half minus minus half, which is 1. And that's why it is left with 1 here. Okay? So I'm going to apply the same concept to here. Okay? So I'm going to take out the common factor. In this case is x plus 4 to the power of negative half. Put a square bracket. So I know I will left with half x minus 3. So half x minus 3 plus, you see this one to the power of half. Same thing. So half minus minus half, so it becomes x plus 4 to the power of 1. So of course I don't really need to bother about the 1. I just write and show it to you. So maybe I can put it here. Okay, so next you need to simplify whatever is inside the square bracket over here. So let's rainbow this part. So this one remain first. So rainbow half x minus 3 over 2 plus x plus 4. So this one is half x plus x, so it's half plus 1. So it's like half plus 1, so we know it's 3 over 2. So this part is 3 over 2x minus 3 over 2 plus 4, minus 1.5 plus 4. So it's 5 over 2 plus 5 over 2, this one. Then x plus 4 to the power of negative half. Then students wonder how to simplify these. This one, change it to single fraction, which is easy. Why? Because the denominator already 2. Agree? So this one actually is just 3x plus 5 over 2. And this, because it's minus half, so I will bring it to the denominator, right? So maybe I just shift the 2, put here, and then this one becomes square root x plus 4. So we are done. Ta-da! So you see, differentiating is not tough. Why? Because all you need to do is keep left, differentiate right, plus keep right, differentiate left. But it's the simplifying that is a tough part. Okay? So the simplifying is you need to take out the common factor. Because the common factor involves the expression and also involves fraction power, and it also involves negative fraction power. So it gets very complex over here. So I have simplified it by this part here. Okay, I have simplified it by this part here, so that it's easier for you to see. I just replace the x minus 3 with y. I replace the x plus 4 with x. So it's easier to see. Okay, so this is how you do product rule. Product rule. Okay, so okay, I'm going to do just one last question for product rule. Okay, the balance of the question, I will do it on this Sunday, 5 to 6 p.m. Okay. So over here, C. So I'm supposed to differentiate x plus 1 to the power of 3, x plus 3 to the power of 5. Again, take a look and see whether this one can expand or not. This one, if I'm going to expand, I think, don't know until when already. So, of course, we know that we're going to use product rule. So, let's do just now as what we did. Keep left, differentiate right, plus keep right, differentiate left. Okay? So, keep left. Differentiate right means that you look at this one, apply chain rule. Power bring down, so it's 5. X plus 3, power minus 1, so it's 4. Multiply by differentiate inside, which is 1. Plus, keep right. Differentiate left. So differentiate left means I'm going to apply chain rule for this one. So it's 3, x plus 1, 3 minus 1, so it's 2. Okay? And then differentiate the inside, which is 1. Okay, before I take out the common factor, let me just simplify it a bit. So, I'm going to write, so it's 5, x plus 1, 3, x plus 3, 4, plus 3, x plus 1 square, x plus 3, 5. So let's take out the common factor. So I'm going to rewrite this at this side here. So if I'm going to write it in terms of like, okay, maybe I should use 5u 3v4 plus 3u square v5. So actually I just replace the x plus 1 with u, x plus 3 with v. So it's easier to see. I'm going to take out what common factor? So you know you need to take out u square, right? Take out u square and v4. And you know that this first term I left with 5u. This one I left with 3v. Can see that? Okay, so I'm going to do the same for this part. So I'm going to take out u square. U square means, you see, I have x plus 1, 3 and 2. Of course, I take out the 2 ma. So I take x plus 1 to the power of 2, x plus 3 to the power of 4, and x plus 3 to the power of 5. Of course, I pick the lower one. So I will take x plus 3 to the power of 4, put the square bracket. First term, after I take out, I left with a 5x plus 1. This one I left with a 3x plus 3. And close it. Okay? Then we simplify whatever is inside the square bracket. So this one just copy. This one just rainbow. So I will get 5x plus 5 plus 3x plus 9. So I will have x plus 1 square, x plus 3, 4. 5x plus 3x, so it's 8x, and then plus 5 plus 9, so it's plus 14. Aha, then you see, this 8x plus 14, actually there's a common factor 2 you can take out, correct? So you're supposed to take out 2 and put it right in the front. So 2x plus 1 square, x plus 3, 4. So you become 4x plus 7. Done. Okay, so answer put the 4x plus 7 at the first bracket, but it doesn't matter. But most important is the 2 must put in front. You don't write x plus 1 square, x plus 3, 4, then suddenly in between got the 2, and then after 4x plus 7. So this is how you do. So again, I write this red color part so that it's easier for you to see how I take out the common factor. So that is product rule. All good? Anyone need me to explain on this last part? This is the last question for the night. I will continue the product and quotient rule next this Sunday, 5 to 6:30. So after this live, I will be posting the event. So for those who want to set reminder, please go to my bio, click on the event and set reminder for this Sunday live. All good?